This is a SpaceX rocket landing autonomously. What you just watched is the result of engineers deeply understanding the relationship between concepts as force, acceleration, and velocity in real time. Today I want to show you a game that puts students in that exact situation. Joe Bowler's research on mathematical tasks argues that the best learning experiences have a low floor and a high ceiling. They're easy to enter, but with real depth to explore. The game is built on that idea. The mission is simple: you have to land a rocket, and you have only one control, which is the throttle. But here's the core design intention. The game gives students a concrete mission and then asks them to figure out how. It does not tell them the physics first, but it makes physics necessary to succeed. That's the motivation, not learn Newton's second law because it's on the test, but I need to understand how force relates to acceleration if I want to beat that score. On the screen, you can see 5 live readouts: net force, acceleration, velocity, altitude, and fuel. And the game is genuinely hard. When students play, they kind of struggle. This is due to the fact that in a lot of simulations, students do something predictable. They figure out the game mechanics through trial and error. They move the slider, they watch what happens, and they kind of build a gut feeling. And they never engage with the actual concepts that is in the explorable. The core design decision here was to make that not enough. And on top of that, there are leaderboards in this game, which means that there's a specific trick that students need to discover, a trick that requires them to actually think about relationships, like how does force affect acceleration, and like how does velocity time graph behave, and what is the possible learning, fastest possible learning time. On top of that, a lot of simulations I've seen are solo experiences. You play, you finish, and you move on. But the leaderboards in this game changes that. When I shared this game with friends, they were really excited. They were saying, I want to be that person. I want to be on the leaderboards. And there are basically small tricks that you need to find before you can go onto the leaderboards. And let me quickly show you those small tricks. So there's this a simple graph, which is a velocity time graph. Velocity is on the y-axis and time is on the x-axis. The rocket starts descending with 100 meters per second velocity, and you have to land the rocket with velocity less than 5 meters per second. And we do know, or the students know that that the area under the velocity time graph represents the distance traveled. Since assuming that rockets only falls and it does not ascend, we can assume that this is the area should stay the same, right? And what we need to do is we need to move the time towards the left. And the only way we can do is by pushing this top line to the top, like this. And one easy way is as whenever the game starts, you can keep the throttle to 0, so it will automatically accelerate. And then at a specific point, you have to move the throttle, or you have to max out the throttle to achieve the maximum deceleration. So this could be the highest deceleration that the rocket is capable of, just like this. Something like this. So you keep the throttle to 0, at a specific time t, and then you maxed out the throttle. And in this way, you can be on the leaderboard. This is a small trick, and this is also elegantly shown in this graph. If you do this strategy, then you can basically be on the leaderboards. Thank you so much for watching.